This is a question with modified setup of Young's double slit experiment. Normally, the main slit will be in line with the central band position. If you draw the perpendicular bisector from central band or midpoint of S1 and S2, the main source of slit will be in line with the position of the central band. So S2 S1 will be equal to S2 S2, SS1 being SS2. The only path difference will be S2P minus S1P. But here the band is the source is slightly shifted upwards. So the SS1 will be less in path, SS2 will be more in path. S1P, S2P remains the same. So they given SS2 minus SS1 becomes lambda by 4. So under that condition, SS2 minus SS1 is lambda by 4 when S is shifted up. What's a new condition for constructive and destructive interference in terms of the path difference from S2 and S1 to P? What will be the new fringe width, bandwidth? When you shift the position of S, the central band is formed where SS1O is equal to SS2O. Initially, if S was here, normal position, SS1O will be equal to SS2O directly. Now SS1 becomes less, SS2 becomes more. Again, the central band is always formed where the total path difference from S to O0. So since this path is less, that should be having more path difference. Since this SS2 is more, that should be less. So that demand the O to shift down if the main slit is shifted upward. Same way when if main slit is shifted down to compensate the path difference to be equal to 0, total path difference to be 0 between SS1O dash to SS2O dash, the O will be shifted up to O dash. So we are going back to the first part of the question, condition for constructive and destructive interference. In interference, the condition for minima, destructive superposition is the path difference equal to 2n minus 1 lambda by 2 with n starting with 1, 2, 3. Here path difference, normally you don't count SS1 and SS2 in the first case with normal setup. But in this experiment, since it's different, we have to count the total path of the first ray as longer path as SS2 plus S2P and the shorter path is SS1 plus S1P. So path difference will be long SS2P path minus the short SS1P. So we split that SS2 plus S2P minus of SS1 plus S1P supposed to be equal to 2n minus 1 lambda by 2, which is the path difference. Now in this, the SS2 minus SS1 is given as lambda by 4. So we separated SS2 minus SS1 plus S2P minus of the bracket S1P equal to 2n minus 1 lambda by 2. Now SS2 minus SS1 you can substitute as lambda by 4. Take lambda by 4 to the other side because our aim is to find S2P minus S1P. Now taking lambda by 4 common, you can solve it or just multiply up and down this term by 2. So it becomes 2 lambda by 4. Lambda by 4 comes out. Here will be 1, will be 2. Opening the bracket will be 2 into 2, 4n minus 2. So 4n minus 2 minus 1. It will be 4n minus 3 times of lambda by 4 as S2P minus S1P. So this is the condition for interference minima or destructive superposition when the main slit is shifted upward in terms of S2P minus S1P. Here n will be same as 1, 2, 3. Similarly, we can find for constructive also. For constructive, the total path difference from S to P is n lambda. where n start with 0, 1, 2, 3. 0 being the position of the central band. Now, same way, the total path difference we have to copy from here, SS2P plus S2P minus SS1 plus S1P equal to n lambda. Now, opening the bracket, taking separate SS2 minus SS1 plus S2P minus S1P equal to n lambda. This you can substitute as again lambda by 4. Take other side. So, n lambda minus lambda by 4. If you take lambda by 4 common out for LCM, 4n minus 1 lambda by 4. So this is the condition for maximum or constructive superposition in terms of S2P minus S1P with n being 0, 1, 2, 3. So the first part is done. For the fringe width, we already calculated S2P minus S1P in the normal bandwidth derivation, because whether you shift up or down, S2P minus S1P will not change. That is already calculated as small d by capital D into yn. This is a part of main normal beta equal to d lambda by d derivation. If you're not fine, you can refer that particular video where this derivation is done. Now from that, yn will be d by d will go other side, S2P minus S1P. For the maxima, we have the condition S2P minus S1P is 4n minus 1 lambda by 4. So substitute 4n minus 1 lambda by 4. This is yn. For y1, put n equal to 1. So 4 minus 1, 3. 3 d lambda by 4d. For y2, 2 into 4, 8 minus 1, 7. 7 d lambda by 4d. Bandwidth will be y2 minus y1. Both bright and dark are same. This is between two bright, it will be the width of dark band. Substituting 7 minus 3, 4. 4 d lambda by 4d will be d lambda by d. So the bandwidth remains same whether you shift up or down, because it depends only on d lambda and d. That is not affected if you shift the main slit up or down. Now to locate the position of the central fringe. Central fringe is normally bright for maximum for interference. So this is a condition for the central fringe. The first central fringe will be with n equal to 0. So in yn formula, substitute n equal to 0. So n equal to 0 will be d lambda by 4d into minus 1. So minus d lambda by 4d. Since minus means it's shifted down, as we discussed in the beginning. When s is shifted up, to make the total path difference between s to the point on the screen 0, the O will be shifted down. This negative sign indicates shifted down. So generally, if this much derivation you end up doing, direct one more question, what you can do for the shift. This d by d always remains same. This lambda by 4 comes from the path difference. That means the shift will be always capital D by small d multiplied by this lambda by 4 or negative. Negative means coming down. So shift of the central band is minus of capital D by d into the path difference, whatever they given in the question. This particular question is lambda by 4, so it will be d by d into lambda by 4 with a negative sign. Negative only means it's shifting down. So this formula can be used just for one more question if you don't want to solve.